23's answer is for the domain negative infinity to 2 and 2 to infinity. Range is negative infinity to 1 and 1 to infinity. B is 0, 0. C is y equals 1. D is x equals 2. E is none. 24A, domain negative infinity to negative 1 to infinity. Range is 0 to infinity. B is 0, 2, and C is y equals 0. D is x equals negative 1. E is none. 25 is negative infinity to 0, 0 to infinity, and your range is negative infinity to infinity. B is negative 1, 0, 1, 0. C is none. D is x equals 0. E is y equals 2x. 26, your domain is negative infinity to 0, 0 to infinity. Your range is negative infinity to negative 2 with a bracket, and 2 to infinity with a bracket. B and C are none. D is x equals 0. E is y equals negative x. For 27, domain is negative infinity to negative 2, negative 2 to 2, 2 to infinity. Your range is negative infinity to 0 with a bracket, and then 1 to infinity with parentheses. B is 0, 0. C is y equals 1. D is x equals 2, and x equals negative 2. E is none. 28, domain is negative infinity to negative 1 to 1, 1 to infinity. Range is negative infinity to infinity. B is 0, 0. C is y equals 0. D is x equals 1, and x equals negative 1. E is none. 42, your vertical asymptote is at x equals 6, and horizontal is at y equals 3. 43, your vertical asymptote is at x equals 2 and x equals 3. Oblique is at y equals x plus 5. For 45, you get a vertical at x equals 1 and x equals negative 1. Horizontal at y equals 0. 48, vertical x equals 0, x equals negative 2. Horizontal y equals 0. 49, vertical at x equals 0, oblique at y equals 3x. 51, vertical at x equals 0 and x equals 1. Slant or oblique at y equals negative x minus 1. For your graphs, here is number 24. That's what your graph should look like. Your domain is negative infinity to negative 1 to 1, 1 to infinity. Your intercept is 0, negative 4. Your problem cannot be simplified. It's symmetric to the y. Its vertical asymptotes are at x equals 1, x equals negative 1. You have a horizontal asymptote at y equals 0. There's your graph for 27. Your equation cannot be simplified. Your domain is negative infinity to 4 and 4 to infinity. Your intercepts are 0, 3, negative 4, 0, 3, 0. No symmetry. You got a vertical asymptote at x equals 4, an oblique asymptote at y equals x plus 5. Here is your graph for 30. You cannot simplify. You get a domain of negative infinity to negative 1 and negative 1 to 1. An asymptote, intercepts at 0, negative 12, 4, 0, negative 3, 0. No symmetry. Vertical asymptote at x equals negative 1, oblique at y equals x minus 2. Alrighty, so then we go, whoa, what happened to the camera? There's your graph for 33. It can be simplified to y equals x plus 4 over x plus 2. So that means you have a whole at 3 7/5. And we have a domain of negative infinity to negative 2, negative 2 to 3, 3 to infinity. There is no symmetry. We got a vertical asymptote at x equals negative 2. We do not have a vertical asymptote at x equals 3 because that was a whole. We have a horizontal asymptote at y equals 1. And intercepts are 0, 2, and negative 4, 0. Notice my whole looks like that on the graph right there. Okay, so 36, there's your graph, and notice it has a whole as well. It simplifies to 4x plus 3 over x minus 3. Your domain is negative infinity to negative 5 over 2, and negative 5 over 2 to 3, and 3 to infinity. You got intercepts at 0, negative 1, and negative 3 fourths 0. No symmetry. Vertical asymptote at x equals 3. You have a whole at negative 5 over 2 and 14 over 11. You have a horizontal asymptote at y equals 4. Here's your graph for 39 with a lovely slant asymptote. We have a domain of negative infinity to 0 and 0 to infinity. No intercepts, origin symmetry, vertical asymptote at x equals 0, and oblique asymptote at y equals x. Please come with questions over these crazy, lovely rational graphs. For next time, we will be reviewing.